class 8. Welcome you to the online class of mathematics. I'm your Bichitra sir. Hope that all of you are fine by the grace of Almighty. Last class we have done one creative from quadrilateral related theorem. Today I will do another creative from Pythagoras theorem, that is chapter 9. So let us start today's session. I think this will help you a lot to realize Pythagoras related creative problems. So let's start today's session. Here is your CQ. In triangle PQR, PQ is perpendicular and on PR, and midpoints of PQ and PR are M and N respectively. PQ is perpendicular on PR, that means angle P is 90 degree. So let us see the questions. Number A, state the converse of Pythagoras theorem with figure. Number B, prove that PQ square plus PR square equal to QR square. And number C, prove that 5RQ square equal to 4 into QN square plus RM square. Now let us start the proof. Solution from A. If the square of any side of any triangle is equal to the sum of the square of other two sides, then the angle between the latter two sides is right angle. That is actually the converse theorem of Pythagoras. That means if sum of two sides square is equals to the third side square, then first two sides included angle should be right angle. Now let us see the figure. Here it is a right angle triangle named ABC. So if in triangle ABC, AC square equal to AB square plus BC square, then the angle between the sides AB and BC, these are the latter two sides, should be right angle, and the angle included between AB and BC is angle B, so angle B should be equals to right angle. That is actually the converse theorem of Pythagoras. Now let us see the proof of B. The general enunciation of B should be like this. If in triangle PQR, PQ is perpendicular on PR, then prove that PQ square plus PR square equal to QR square. That means in triangle PQR, if angle P is right angle, then we have to prove hypotenuse square equals to adjacent square plus opposite square. That is actually the proof of Pythagoras, and I have tried to make this proof with the similar triangles concept. So let us see the proof. At first, after general enunciation, there should be figure. So here is the figure, and the names of the sides are this P, Q, R, and the small form, small alphabets actually indicating the sides name, like PQ equals to R, PR equals to Q, and QR equals to P. Now let us see the particular enunciation. Let PQR is a right angle triangle where angle P equals to 1 right angle, PQ equals to R, QR equals to P, and PR equals to Q. Now it is required to prove that PQ square plus PR square equal to QR square, or in another sense we can say P square equal to R square plus Q square. Smaller hand P square equals to small Q square plus small R square. So that actually we have to prove. To make this proof, we have to make some construction. So let us see the construction. Draw perpendicular PH from P to QR such that H divides QR into two parts, S and T, so that S plus T equal to P. That means P split into two parts. There's a S and T, and that should be like this. Let us see the construction on the figure. The perpendicular drawn from P to QR, that is PH, and that H divides QR into S into T, so S plus T equal to P. Now the proof. At first, let us see in triangle PHR, because PH divides the PQR triangle in two triangle, and one is PHR and another is PHQ. So let us at first see between triangle PHR and PQR. The angle PHR and the angle QPR is same because both are right angle, and the angle PRH equals to angle PRQ because both indicating the angle R. This angle was indicating by this angle. This is the angle which they are indicating. So we can say that both of triangles are similar, because if two angles are equal to the other two angles of another triangle, then the third angle obviously should be same or equal, and in this sense we can say both of the triangles are similar. When three angles of a triangle are equal to the three angles of another triangle, then they are say similar triangles. And by the concept of similar triangles, we can say the similar sides ratio should be same. So here we have showed in APHR and in PQR triangles, HR divided PR, HR from PHR and PR from PQR equals to PR divided QR. So in the numerator we have showed the sides of PHR triangle, and the denominator we have showed the sides of triangle PQR. Now HR represent by T and PR represent by Q and QR represent by P. So if we replace them by that short form, then it is like T by Q equals to Q by P. Now if we make the cross multiplication, then it should be like this: Q square equal to PT. Let us give it is equation number 1. Then in triangle PQH and PQR, like similarly from the previous concept, PHQ equals to QPR, both are right angle. PQH and PQR are the same angle indicating, so both the triangles are similar again. So by the same concept we can say that similar sides of two triangles ratios should be same. So the similar sides of PQH and PQR triangles are ratios the same. So HQ by PQ equals to PQ by QR. HQ represented by S and PQ represented by R and QR represented by P. So in short form it is like S by R equals to R by P. So if you make the cross multiplication, it becomes R square equal to PS. Now if we add 1 and 2, so we get like this: Q square plus R square equals to PT plus PS. Now if we take P common from right hand side, so it looks like this: P into T plus S, and T plus S means P, it has been from construction, so we replace T plus S by P, so P into P becomes P square. So this form becomes Q square plus R square equal to P square, which means Q square plus PR square equal to QR square. That was the proof of B, that means Pythagoras theorem. Now let us start the proof of C. At first let us see the general enunciation. If in triangle PQR, PQ is perpendicular on PR and midpoints of PQ and PR are M and N respectively, then prove that 5RQ square equal to 4Q1 square plus RM square. Here PQ is perpendicular on PR, that means angle P is right angle. So let us see the figure at first. Here is the figure. PQ in triangle, N is the midpoint of PR and M is the midpoint of PQ. So let us start the particular enunciation. Let PQR is a right angle triangle where angle P is right angle. M and N are the midpoints of PQ and PR respectively. It is required to prove that 5rq square equals to 4 into qn square plus rm square. We don't need any construction here, so let us start from the proof. At first, in PQR, if we apply Pythagoras theorem, because angle P is right angle, so we can have QR square equals to PQ square plus QR square. QR square equals to PQ square plus PR square. Now, if we take the triangle PQN, here also QPN is right angle, so again applying Pythagoras theorem, we can have QN square equals to PQ square plus PN square. If we take PQ on one side and take PN on other side, it becomes PQ square equal to QN square minus PN square. Similarly, from triangle PMR, we also get PR square equals to RM square minus PM square. Now, if we use this two value in number 1, that is PQ square plus PR square equal to QR square, so we get QR square equals to QN square minus PN square plus RM square minus PM square. Now take the positive, if we simplify this, like Q1 square plus RM square minus, take common from both minus, then it becomes Pn square plus Pn square plus Pm square. Now Pn is half of PR, so we can write PR by 2 whole square, and Pm is the half of PQ, so PQ by 2 whole square. Now it represented by PR square divided by 4 and PQ square divided by 4. All the remaining terms are same, so we didn't make any changes over there. So it looks like QR square equal to QN square plus RM square minus PR square by 4 plus PQ square by 4. If we multiply the whole equation by 4, we get like this: 4QR square equal to 4QN square plus 4RM square minus PR square plus PQ square. Now this PR square and PQ square becomes QR square, so we can write 4QR square equal to 4QN square plus 4RM square minus QR square. Take this QR square on the left side, the minus QR square on the left side, it becomes 4Q square QR square plus QR square equals to 4QN square plus 4RM square. So it becomes 5QR square on the left side, and if you take 4 common from the right hand side, it becomes 4 into QN square plus RM square. So that was the required proof. 5QR square equals to 4 into QN square plus RM square. So boys, here you saw how to prove Pythagoras concept and Pythagoras, using that Pythagoras concept, other problem. I hope this will help you to realize the chapter. In next class, we will try to do another creative from another topic. Till then, study properly and stay safe at home. So, bye for today.